Alrighty, today we're going to be talking about stoichiometry, and we're going to do the first few steps in stoichiometry and when we use it. So the reason we use stoichiometry is when we're looking at a full reactions. What we're specifically talking about with stoichiometry, it really comes down to mole ratios. So for this, you can use your no-think method to solve any stoichiometry problem. So we're going to do a few together. And then you can do some as practice as well. So this first problem, what mass of hydrogen can be produced by reacting 6.0 mole of aluminum with hydrochloric acid? So the first thing we need to do is make sure that our reaction is balanced. This one's already balanced for us, so we're good. So step one, balance. That's the first thing you have to do with stoichiometry. Make sure that your reaction is balanced. Since this is already balanced, we're good to go. So, second thing, we write what we are given. So in this case, what we're given 6 moles of aluminum. So that's what we're going to start off with. That's what we're given. So we have 6 mole. Third, we got to figure out where we're going. Stoichiometry is a roadmap of the reaction. So we're going from moles of aluminum, and we are going to mass of hydrogen. So we're going to grams of H2. So what we do for the mole ratio, we look at the coefficients. So we're going to have times in a line. I got to get rid of moles of aluminum, so that's going to go on the bottom. Going to hydrogen, so we're able, with this coefficients of this balanced reactions, those are the mole ratios. So we can go from moles of aluminum to moles of H2. Now what is that ratio? Well, in this reaction, we use 2 moles of aluminum, so that's going to be number down here, 2, and then we get 3 moles of hydrogen. So that's going to come down there. So the mole ratios are the coefficients. Now we're still not done yet because it asks for the mass. So I'm going to erase these steps over here to give myself some more room. So these moles of aluminum cancel out. Now we got to go from moles to grams. And to do that, we just use our molar mass. So we know that 1 mole of H2 go on bottom, grams of H2 is going to go on top. And for today's purpose, we're just going to say it's 2 grams. We're going to round. Alright, then we just plug this into our calculator. 6 times 3 divided by 2 times 2. We are left with 18 grams of H2. So there's our final answer, 18 grams of H2. So let's do another one. Alright, so this problem. If 5.3 grams of aluminum chloride are produced, how many moles of hydrochloric acid were needed? So now we're going to start with grams of aluminum chloride. So we have 5.3 grams AlCO3. And we're trying to go from this grams to moles of HCl. How you doing?
Just proud you're not taping, are you?
I am. You want to say hi?
No.
You sure?
Sorry.
Don't worry about it. So we're going from grams to moles of HCl. Grams of aluminum chloride to moles of HCl. So the first thing we have to do, we got to get that grams to moles. Grams to moles. Bottom, moles on top. Do that by getting our molar mass. 1 mole. Aluminum's molar mass is 26.9 plus chlorine's 35.45 times by 3, 26.9 plus 3 times 35.45. And we get 133.25 grams per 1 mole of aluminum chloride. We're still not to moles of HCl, so we got to use the mole ratio.
Miss Ebner, can you please come by or call extension 403? Thank you.
And Miss Ebner is going to be talking to Miss Sellers soon. So we got one more time to the line. We got to get rid of moles of aluminum chloride, so that's going to go on bottom. And we're trying to get to moles of HCl, so that's going to go on top. So for every 2 moles of aluminum chloride, we need 6 moles of HCl. So now we can just plug it into our calculator. 105.3 divided by 133.25 times 6 divided by 2, and we get 0.11 mole. And that is how we do stoichiometry. So stoichiometry is all about the mole ratios.